Here you see a small one of the larger the model. I made from some parts I have laying around. I found some. Here will be the underwater line driving rod for the displacer. This setup, of course, will be flipped around when it's finished. So the water level will be about here, and water will be submerged outside here in a larger container here. And then there will be a charging pipe here, an elbow. I don't have the elbow here. And then I will have a long charging pipe. The mass in the charging pump is actually the hydraulic flywheel, and the mass, the length, diameter, and so on, the shape, combined with the amount of air, set the frequency of the water pump Stirling engine. The frequency, of course, will be much lower compared to the biochar run, and that's important because then it's more isothermal. And in IC you don't need isothermal behavior, but in Ericsson cycle and Stirling cycle it's very beneficial to have isothermalizer. So this will be plates for the isothermalizer instead of these 50 microns, who are a bit lighter, but this is easier to find. Actually, if someone doubt about my ideas, I could say I have built 9 of these type of before. 9 of these water pump Stirling in different shapes and so on. And the difference is now is I replace styrofoam, the plastic displacer, with this beautiful, wonderful material, foam glass, who's behave like plastic styrofoam, but it will not melt. Actually, I have built one medium temperature Stirling engine. I put a stove on, put some wood on, burn, and it pump a steel vessel or a steel container, and it works. It's pumped very high pressure and so on, back and forth. But I was feeling this kind of material I use then. I feel a container, aluminium container with these act as a regenerator material, an isolator between the hot and cold. I didn't remember, about 2 decimeters of these materials. But this is not so nice because it's heavier than the foam glass. It sucks up some of the water, and it's too much dead space. Dead space is an obstacle in all Stirling engine, and that is a trade-off you have to deal with. And if you compare it to Ericsson cycle, I have built one Ericsson cycle also. The benefit of the Ericsson cycle is that you do not have dead space. You have valves between the compressor and expander, and between that valves, then you have the heater and so on. So you can have an exchanger who is as large as you want. You do not add dead space. So dead space is an obstacle in Stirling engine compared to the Ericsson engine. Ericsson engine, on the other hand, have valves you have, and actually hot valves you have to manufacture, and that's difficult. Both engines, it's an advantage if you have isothermalizer in both expander and compressor in Ericsson cycle as well. Of course, you can build a displacer with this kind of structure, but this needs more advanced workshop and tools. It's expensive materials, and you need stainless steel. It's heavier, and you have to make trade-off between how thick plates and weights of this. I mean, this is heavier than the glass foam, and it's smaller than the glass foam. I could add more height of my glass foam displacer, and it anyway was more lightweight. And of course, so I will not use this one. It's a beautiful evening today. Actually, that is a beautiful way to produce electricity. Of course, that's the obvious way, I would say. Anyway, my end goal, if this works out great, I will build a batch charcoal production tank. You could put in wood and produce charcoal, and I figure out that somewhere between 350 to 600 Celsius is an temperature range. But I guess when you put in a lot of woods like this, for instance, then you have a very high power on a short terms of period, and then my idea is to charge a tank with sand with that heat, and then I could extract that heat during the whole night or so by air flowing around the top part of the, actually this will be the top part here. So I will have 350 degrees of hot air circulate to the container with sand, and then I can control that so I have an sufficient temperature during the whole process, and when I extract the heat from the sand. So that's the end idea of this. And here is the glass going up and down 2 decimeter around that. Maybe if I have loads of time, I will have this stirling engine as the second stage of heat extraction. The first state, if I have from the charcoal production from that, I mean, I have a lot of like that. Maybe I will use that. When I produce charcoal, I have a lot of 600 degrees of heat, and maybe I run Ericsson cycle, a classic Ericsson cycle with that heat, and then I as a first stage of high power extraction, and then the second stage will be this, but that's just an idea. Anyway, I think store the heat in a sand box and then extract it to this will be rather easy. All right, that's enough for today. Have a nice evening or day or night.